Chapter 6.1, Day 1, Exponential Growth and Decay. An exponential function has the form y equals a b to the power x, where a is not equal to 0 and the base b is a positive real number other than 1. If a is greater than 0, which means that this number would be 1, 2, 3, 4, and so on, and b is greater than 1, then y equals a b to the power x is an exponential growth function. B is called the growth factor. The simplest type of exponential growth function has the form y equals b to the power x. Parent function for exponential growth functions. The function fx equals b to the power x, where b is greater than 1, is the parent function for the family of exponential growth functions with base b. The x-axis is an asymptote of the graph. An asymptote is a line that a graph approaches more and more closely. The graph rises from left to right, passing through the point 0, 1 and 1, b. The domain of fx equals b to the power x is negative infinity to infinity. In other words, it's also called all real numbers. And the range is 0 to infinity. And in another way, you can say that y is greater than 0. So now I'm going to graph this growth function to see how it looks like. And it's said here that x-axis is a asymptote. Asymptote is a line where the graph approaches more and more closely to this line. And it said also that the graph rises from left to right and it passes through 0, 1. 0, 1, let's say, is this point right here, 0, 1. And the graph is, it looks like this. So what do you notice here in this graph? That it passes through 0, 1. And in this direction, it's going to approach to the x-axis line, or is getting closer and closer to the x-axis line. And this x-axis line is called asymptote. So asymptote is a line that a graph approaches more and more closely. So the graph is approaching more and more closely to this line. So that's why this line, which is x-axis, is called asymptote. If you talk about the domain and range of this graph, you can see that the x is approaching to negative infinity forever and on the positive side forever. But whereas if you talk about the y line is starting from above the 0, because down here y is less than 0. From this line above, y is greater than 0. So that's why the range, or the y, is greater than 0. So it's going to only on the upper side of this line. So that's why the range is 0, infinity, or y is greater than 0. So whenever you talk about a growth graph, so this one is an example of a growth graph where b is greater than 1 and a is always greater than 0. B should be greater than 1. Then it's a growth graph that always rise from left to right. So growth graph always rise from left to right. When we discuss the decay graph, is going to always fall from left to right, which is the next part we are going to discuss. Parent function for exponential decays. So we are going to discuss the decay function. If A is greater than 0 and B is greater than 0 but less than 1, which means that it's going to be 1 over 2, 1 over 3, 1 over 4, 2 over 4, and something like that, where the B is less than 1, then y equals ab to the power x is an exponential decay function, and b is called decay factor. The function fx equals b to the power x, where b is greater than 0 and less than 1, is the parent function for the family of exponential decay functions with base b. The graph falls from left to right, passing through the point 0, 1 and 1, b. The x-axis, which is this line, is an asymptote of the graph. The domain of fx equals b to the power x is negative infinity to infinity, which means all real numbers, and range is 0, infinity, which means that y is greater than 0, or the graph will stay above the x-axis. Now this is the x-axis line, which is an asymptote. Since this is a decay function, so this graph is going to fall from left to right. So this graph going to look like this, and you can see that the graph is falling from left to right. The graph falls from left to right, and the point they cut off is 0, 1, similarly as growth function. And this graph is fx equals b to the power x, and then b is going to be less than 1. Another point is going to pass through is 1, 1, b. So these are the two definite points the graph is going to cut at, 0, 1 and 1, b, for the parent decay function. X-axis is the asymptote. Asymptote is the line where the graph is approaching this line or getting closer and closer. Domain of this function is going to go to the left forever and right forever. So it means it's negative infinity to infinity, or all real number. This graph is above the x-axis. It means this is greater than 0. So y is greater than 0. So example number 1, graphing exponential growth and decay function. So one example, that letter A we are going to do for a growth function, because in this case b is greater than 1. And the next example will be a decay function. We're going to have to tell whether each function represents exponential growth or exponential decay. Then we are going to graph it. So let's see again. Step number 1, identify the value of the base and see if it is greater than 1 or less than 1. What is the base here? So base is b, that is b equals 2, and it is greater than 1. So we will call, therefore, it is an exponential growth function. So b is greater than 1. Now we're going to have to graph it. We're going to choose some x values on our own and then find out the y value. So let's choose some x value here. So we're going to choose -2, -1, 0, 1, 2, and 3. These are the typical x value we choose. And now we're going to figure out what is going to be our y value. So we're going to use this x value, plug it in here, and see what is the y value. So y equals 2 to the power negative 2. 2 to the power negative 2 is 1 over 2 to the power 2, and that is 1 over 4. Next, we're going to use 2 to the power negative 1, and that would give me 1 over 2. So 1 over 2 for this one. Next, we're going to choose y equals 2 to the power 0. Anything to the power 0 is going to be 1. So when you plug 0, you got y value as 1. Next is y equals 2 to the power 1, and that is simply 2. When you put x as 2, so 2 to the power 2 is 4. Y equals 2 to the power 3. 2 to the power 3 is 8. So this is going to be 8. You can also, to make it easier in the graph, you can make it 1 over 4 is 0.25. And 1/2 means 0.5. It just gives us a little bit easier way to graph. So negative 2 comma 0.5 is this point right here. Half, negative 1 comma half is in the center. 0 comma 1 is this point. 1 comma 2 and 2 comma 4. You graph these or connect these points, and you're going to get a function that looks like this, and it is a growth function. So after finding the point, you're going to plot the points, draw from left to right a smooth curve that begins just above the x-axis, passes through the plotted points, and move up to the right. For this one, again, if you want to write domain is all real numbers or negative infinity to infinity, and range, you can see that is above the x-axis, all real numbers. Y is greater than 0. Now you're going to tell whether this function is a decay or a growth. So first of all, you're going to identify the value of the base. So the base in this case is 1 over 2, and that is less than 1. So it's less than 1, then therefore this is going to be an exponential decay function. Now I'm going to choose the x values and plug it into the given function here to find out the points and plot those points to get the graph. The points that I'm going to choose this time is -3, -2, -1, 0, 1, and 2. The typical points that we normally choose for x. Next, I'm going to put these points for the x value into the given function. So what we got here is 1 over 2 to the power -3. Once you have a negative power, you're going to flip it. So it's going to be 2 over 1 to the power 3, and that's going to be 8. In this case, 1 over 2 to the power -2. Flip it because you're going to make the power positive. 2 to the power 2 is 4, so that's going to be 4. 1 over 2 to the power -1, and that's 2 over 1 to the power 1. So this is the point. Next, you're going to plug it in 0, and then anything, doesn't matter the base. If you have a exponent 0, then the answer is always 1. 1 over 2 to the power 1 is just 1 over 2 or 0.5. Next, you're going to put x as 2, so 1 over 2 to the power 2, and that's going to be 1 over 4. And you can turn that 1 over 4 into 0.25, and then half means 0.5. That will be easier to graph. So negative 3 comma 8. So negative 3 comma 8 would be out of the chart. So let's assume like right there. Negative 2 comma 4 is this point. Negative 1 comma 2 is this point right here. 0 comma 1. 1 comma half, so right in the middle. 2 comma 2.5, so right there. You want to make a smooth graph, so it doesn't matter how you connect and how you feel comfortable connecting it. So let me try connecting from this side because I want my graph to be smooth as possible. And here I'm going to make an arrow to show that this graph is approaching the x-axis line because this is my asymptote line. Decay graph falling from left to right and is passing through point 0 comma 1 here.